Okay, continuing number 30. This should be short because we uh, already did all the work, right? Our rational roots, theorem, synthetic division, factoring by grouping. So now we have, I just went ahead and I wrote out what we had. So we found our four roots, right? Notice these guys, right? These are my, again, integral, right? They're integer roots, integral roots, right? And these guys are my complex conjugate roots. Okay, so this is going to have a certain form, right, when we write the solution, and then this is going to have a certain form. Okay, so one thing I do want to point out is, well, I mean, our complex roots, right, have the form a plus bi, and again, I emphasize this 0 because that's going to be my a, and then my b is going to be the radical 3. So maybe a is 0 and b is radical 3. Okay, the I is not part of it because a and b are real numbers, and these are real numbers. Okay, so let's start writing out the solution. So y of x is equal to, I'm going to start with my r1, which is -1, so that's going to be c1 e to the r1x. Well, that's just -1x or negative x. That's a negative x plus c2 e to the r2x. Okay, well, that's just 2x, so check, check. Okay, so this is done, but now my form's going to look a little bit, it's going to be a little bit different for the complex solutions. By Theorem 3, we have plus, and we have e to the ax. So I'm on page 131, e to the ax. Okay, what's my a? It's right here. A times x. And then we have c1 times cosine of bx. Okay, so what's my b? My b is radical 3. And actually, let me insert that 0 since that's my a as well. I mean, they're not the same, but x, and I write really big, so I'm going to scooch this over really quick. X plus c2 sine of, again, radical 3 x. Okay, so here is, right, I'm using theorem 3, right, and then this first one is theorem, I believe, 2, or I'm just kidding, theorem 1, right, distinct real roots, because I have two roots and they're definitely distinct, they're different. No repeated roots in this case. If you did, then you would use a repeated roots theorem. And that's, well, that's pretty much it. We can just simplify this a little bit. Okay, so c1 e to the negative x plus c2 e to the 2x plus, and this guy, well, that's just e to the 0, which is 1. So we have, well, then we just have c1 cosine times radical 3x plus c2 sine of radical 3x. And the book actually writes your radical 3x as x radical 3, which is completely fine. They probably do that just because they don't want you to write the x under the radical, just similar to the whole I idea where, I mean, you can't have, well, the x is not under the radical. In this case, it's x times, radical 3. That is your final solution. So make sure you know how to do these, because you will see a lot of this on your exam. So make sure to get comfortable with synthetic division and maybe review your factoring techniques if necessary.